Another lecture. Today, we would like to talk about how we can create a class for complex numbers in C++. And basically, we would like to create a class that can create complex numbers and can perform addition and subtraction on complex numbers. Later on, I will ask you guys to add multiplication as well as division to this class to complete the code. Okay, so let's get started. I'm gonna open Visual Studio and I'm gonna create a new project. So I'm gonna use an empty project. I'm gonna call it project underline complex underline 1, and you can choose whatever folder that you like to save your data. And I just go ahead and create the project. Okay, now this is my project, and I'm gonna create my main file that is the source file for this program. And later on, I'm gonna initiate the complex class. Now I'm going to project and I'm going to add a new item. And this is going to be a CPP file, the main file, and we can just call it source as it is. And I'm going to add it. Okay, we just created the source file, as you can see here, CPP file here, and we're going to just add the minimum requirement for this source file. I'm going to use using namespace standard, and I'm gonna include input output stream here, and I'm gonna create my main. Later on, we may need to add more libraries or include our class here, but for now, let's just create the main. So let's create this function, integer main, and let's say it just return 0. Okay. So let's quickly run it and see everything is working properly. Okay. So this seems to be working. Now, the next thing that I would like to add here is that I'm gonna add a class, a new class here. So I'm going to project. This time I'm gonna click on add a class, and I'm gonna call this class complex. And as you can see, when I add the class, it creates my header file, complex.h and complex.cpp. And essentially, header is where I introduce the template of my class. And the CPP file is the file that includes all the details about those templates. And later on, in more advanced type of programming, you can hide the CPP file so the user can just see the template of all of your function that you have in your class. Okay, I just created this class, and as you can see here, I have the header and I have the complex.cpp. Now, It's very interesting that when I created this class, in the CPP file, by default, it added the complex.h, meaning that it will include my class in this CPP file as well. I'm gonna go ahead and add complex.h to my main file as well, so it is there as well. And I'm gonna start here in a complex class, and step by step I'm gonna add the required input to create this class. I'm just gonna go ahead and include using namespace standard and IO stream here in my header file, as well as in my CPP file for the class. And I'm gonna just start working with my class. Okay, so you guys know that when we have a class, usually this class has different attributes. In this case, for a complex number, we have the real part and imaginary part, and each of these real and imaginary part can have different instances. So I'm going to create these real and imaginary part in my header file. Okay, so you should remember that in a class, by default, any variable or item would be private. What does that mean? It means that from the source, I cannot directly access those variables. Now, I can go ahead and type public here and make a real and imaginary uh, variable in my class public and accessible through the source, but that is not a good programming practice. So what should we do alternatively? Alternative thing to do is that we let real and imaginary be private as it is by default, but I'm going to create a bunch of functions that will let me indirectly access these variables, okay? Okay, so let's define a bunch of function here. So the first function that I would like to define is a function that actually can set the value for real and imaginary part. Let's call this function set value, and let's have two variable here for the real part of my imaginary number and for another double for imaginary part of my imaginary number as it is. Okay. So right now, this red line underneath of this function informing me that we got to make sure that if this going to be a void or it's going to be integer or it's going to return something or not. Now this one is not going to return anything, so I'm going to just put void, so it's not going to return anything for me. Now it gives me another error and it tells me that the definition for this function is not available. Now what we need to do is that we're going to go to the complex, and here we're going to define this function that we just introduced the template in the header file. Okay, so you can also just easily go here and then click on here, so it will automatically create these function in the complex.cpp file. This is the same function that you see it open in the header. So you can close it here, and you see that it automatically generates for me. Essentially, it's the same function, but it just added this complex colon set value. So it's just telling us that this belongs to this class. Now, what I'm going to do here is that I'm going to say that it's going to define the real part of my class to be R, and the imaginary part of my class to be just I. So I indirectly, what I did here is that I indirectly introduce the real and imaginary component, like these two, which are private, through these set value functions. So now if I go to the source and let's say I defined complex Z, okay, and it should be with capital C, then if I type Z dot set values, let's say 1 and 2, then it create my complex instance Z, and it assign the value of 1 and 2 to the real and imaginary part of this complex value. Okay, so let me just go ahead and run it at this stage before I move further forward and see if there is any error or the code just run well. So we don't have any error at this time, so I'm gonna continue working on this problem. It's a good practice whenever you add like a new line or new function or something, you just run it and make sure that everything works the way that you want. Okay, now I indirectly introduce real and imaginary component of my complex class. Now, the next thing that I would like to do is that I would like to actually be able to access to these values. So to do that, I'm gonna create two other function, double get real, and this function gonna create gonna provide access to the real component of a complex number. Okay, now as before, you see that it provide some warning, and it's telling me that you got to create a definition for this function that you already provide the template in the header, but go to the CPP file and actually provide the definition. And I hit enter, and in the CPP file, automatically it generates this file for me, and I'm gonna just ask to return the real. Okay, and let's go ahead and in the source file actually see if this works. So I'm gonna see out. Z dot get real. And if it works, it should just type print out 1. Okay, so let's run it one more time here. Okay, so it typed 1 for me. So far, so good. So similarly, I can create another function that this time is gonna give me the imaginary part. And okay, so once again, it asked me to create the definition in the complex file, and there we go. This time it's just gonna return the image. Okay, perfect. Now I'm going to my source file, and I'm gonna type z.get image. And essentially what's gonna happen is that it's gonna provide the imaginary part of my complex number. So if I run it one more time, it should provide the imaginary part and real part. But then when we show a complex number, we would like to also show I or J, it doesn't matter, as the actual complex variable. So let's run it one more time and see if we have any error or this gonna actually work. Okay, so I just was able to type 1 plus 2i. So I was able to define my complex number, and I was able to define its value and print it out to the workspace. Now, I wanna, at this point, I wanna create a constructor, okay? So a constructor is a very simple method to initialize the value of my variable in a class. And in this case, I'm going to start with the complex double and real I. And what this does for me is that it can initialize the real and imaginary part of any new complex number, and it's going to simplify the introduction of the classes. I'm going to fix it just by defining this class in my CPP file, and here we go. I'm going to just copy paste this one. Essentially, set value is like same as this constructor was. Constructor is will do the same thing in a much easier way. Now let's see if we can use this constructor instead of set value. I'm gonna comment this line, and here, because now I introduced the constructor, I can just type 1 and 2 directly here. And it will create a complex number where the real part is 1, imaginary part is 2. Gonna run it one more time and make sure that everything works the way we want it. Okay, so this works well. One last thing, I can also have a simpler constructor here that does not get any input from the user and just initializes the real and imaginary part to 0. Let's just go ahead and create this constructor also in the CPP file. I just use this one, copy, paste it here, but instead of R and I, I'm going to just introduce 0 and 0. Okay, now I'm going to the source file, and this time I'm just typing Z without any input. Now, if it works correct, it's just gonna show a print Z plus Z times I. So let's just run it one more time and make sure that it works the way we want it. Okay, so we're good there in terms of constructor and setting and getting the values. Now let's go ahead and actually define a plus operation in this new class. Now, we're going to use something that we call it operator overwriting, and this is how we do it. I'm gonna first work with the summation. So if I'm adding two complex number, the output would also be a complex number. Okay, then I'm going to use the summation operator. So I'm going to type operator and then add the summation, and it's going to be a complex number again. And let's call this complex number Z. And now we're gonna once again create the definition in the CPP file. If you take a look at the CPP file, you would see that it just generated this new function, which essentially override the plus sign in C++ because C++, if you do not introduce any complex library, by default, it just works with the double numbers. Now, what I'm going to do is that I'm going to create a new number, complex number. I'm going to call it double Z. And then I'm going to say that Z dot real, the real part of this number, is actually real plus Z dot real. Now, pay attention. When we are using the summation operator, there is one variable before it and then one variable after it. So this real is from the existing complex number that comes here before the plus sign, and then the other variable we just introduce it as Z, so that the real part of that would be Z dot real, and then this new variable double Z dot real. This is how we introduce its real part, and I'm gonna go ahead and create its imaginary part, which gonna be image plus Z dot image semicolon, and I'm gonna return ZZ or double Z as my variable. Okay, now let's go ahead and perform a summation in my source file 2 and let's say or 3 and 4. Okay. Now let us let me just remove this for now, and let us introduce this one as Z1 and this one as Z2, and also let's introduce our Z3. Okay, and then Z3 gonna be Z1 plus Z2, and let us print out Z3 here. So now if everything works fine, Z3, it will show 1 plus 3, 4, 2 plus 4, 6, I. Let's run it and see how it works. Okay, so it works according to the equation. So 4 plus 6i. Okay, so far so good. Now I'm gonna go ahead and create a similar function for the subtraction. Now for case of subtraction, it would be the same. I just need to go ahead and create the detail in the C plus CPP file here. And essentially it's going to be the same as this guy. I'm going to copy, paste it right here. The only difference is that we use a subtraction instead of plus, minus sign instead of plus sign. And in my source file, let's perform the subtraction. Now, if it works fine, 1 minus 3 would be minus 2, and 2 minus 4 would be minus 2 as well. And let's go ahead and run it one more time. Okay, so this also seems to work fine. The only thing is that we have plus minus 2 here, okay, which is fine, but it's not, let's say, nice way to write, okay? So we're gonna fix this issue. And we are gonna also do one more thing. You see, we overwrite the operator plus and minus. Now we're gonna go ahead and overwrite the insertion operator, okay? And so it can handle writing out the complex numbers. Okay, so I'm going to my template, the header file that I have, and I want to add a new function here, but I'm not going to include it in my class. The reason why I'm not including in my class is that this new function, the insertion operator, is not from the complex class. Okay, it's from the operator insertion operator class, and I'm gonna define it like this: OStream ampersand is gonna be the type of the output for this function, and I'm gonna use operator, and I'm gonna type insertion, and what it's gonna receive is that it's gonna receive a OStream variable. Let's call it out, and it's gonna also receive a complex variable. Let's call it z, and that's it. So we're gonna create the definition of this operator in the complex file. Okay, I'm gonna return stream file, and it's gonna be z dot real it's gonna be z dot real, and then I'm gonna go ahead and put the plus sign and z dot imaginary. I'm gonna go ahead and put I, and okay. So if this works fine, the insertion operator now should be able to handle printing a complex number. So I'm going to my source file one more time, and I'm gonna instead of this, I'm gonna directly type Z3. Okay, and I'm gonna run it to see if it can show my complex number. Okay, so it works fine, -2 minus plus minus 2i, but I'm gonna make it better by removing this plus sign. So I'm going to my CPP file, and I'm going to use a if statement. I'm going to say if z dot image, if the imaginary part of my number is bigger or is equal to 0, then return this, else go ahead and return something different. So if the imaginary part is positive, we're going to have a plus. But if imaginary part is negative, we don't need to add anything here. So because it already include the minus sign there, and this should be work just fine by using this if statement. Now, let me go ahead and run it one more time in the source file and see. Okay, now looks much better. 2 minus 2i. Now, just to make sure it's okay, let me just change it to a plus and run it one more time. And this time 4 plus 6i. So I think now this conclude this tutorial. In summary, we were able to create a class, complex class in our C++ code. We call this class complex, and we define our constructor to initialize the value for the real and imaginary part. Then we provide these functions to indirectly access the real and imaginary numbers in our class, and we also override the plus and minus operator in our C++ file. And finally, we override the insertion operator in the C++ so it can handle printing out complex numbers. And these are the detail in our CPP file. And what I would like to ask you guys to do at this point is that overwrite the multiplication and division operator as well, and complete this lab. Okay, thank you so much for your attention, and see you guys soon.